Okay, so get this. We're going to deep dive into what would happen if you pitched a baseball.
At almost the speed of light.
Yeah, at nearly the speed of light.
Yeah,
You might think home run, right?
not quite.
Wrong. More like bye-bye Earth.
It's a classic physics thought experiment. We can't actually do this, but exploring the theoretical fallout is what makes it so fascinating.
So first things first. What happens to the baseball itself as it approaches light speed?
Its mass increases dramatically. And I mean dramatically. The closer to light speed, the heavier it gets, approaching infinity.
Hold on. So it's like trying to throw a pebble and then suddenly it's like pitching a boulder?
Exactly. Then a mountain. Then a planet.
Okay, whoa. Yeah.
That's why nothing with mass can actually reach the speed of light. It would require infinite energy to move something infinitely massive.
So that's impossible. Got it. But let's pretend we can make this super heavy baseball move.
Or
What happens next?
air.
Air. Air resistance. I'm picturing some serious wind.
More like nuclear fusion.
Huge.
The energy from the baseball colliding with air molecules at that speed would be so intense it would fuse atoms together.
Isn't that what happens inside the sun?
Basically, we're talking star-level reactions from a baseball.
No, we're talking star-level reactions from a baseball.
Okay.
So we're way past a fastball here. To really grasp the scale, how much energy are we talking about with this?
You know how we measure really big explosions in megatons,
Yeah.
like nuclear bombs?
Yeah.
This baseball would be packing that kind of punch.
Multiple megatons?
Multiple megatons.
Yeah.
Enough to wipe out a city.
Easily.
So not just a broken window, we're talking a city-sized crater.
Got it.
Think. But it doesn't just stop there, right? What happens after this insane explosion?
Imagine a blast wave flattening everything for miles. The heat would be so intense, everything would burst into flames. And then there's the radiation.
Oh, right, because it's basically a nuke going off. How bad would the radiation be?
Think a flood of gamma rays and other high-energy particles lethal to anything nearby, and it would contaminate the area for a very long time. So even if you're miles away, you're fried by the heat and then poisoned by the radiation grim.
And we haven't even talked about what all that debris and dust thrown into the atmosphere would do.
Mm.
It could block out the sun, leading to a nuclear winter effect.
So the whole planet gets messed up, not just the impact zone. This baseball is basically causing an extinction-level event then.
Pretty much. Like a massive asteroid hitting Earth or a full-blown nuclear war, and all from something you can hold in your hand.
This is giving me a whole new perspective on baseball, but there's got to be more to this story, right? Like, what does all this look like from the baseball's perspective? That's what I really want to know.
Now that is where things get truly mind-bending. That's exactly where we're headed next.
Okay, my brain is officially fried after that last bit. So we talked about what happens to the world when this super fast baseball goes rogue. But what about the baseball's experience? Does it even know it's about to cause the apocalypse?
That's where we really dive into Einstein's theory of relativity. And trust me, it's a wild ride. One of the mind-boggling consequences is something called time dilation.
Okay, I've heard of that, but it always makes my head spin. Does that mean our baseball is basically a time traveler?
In a way, yes. Time dilation means that time actually slows down for an object that's moving super fast, relative to someone standing still.
Okay, so if I'm watching from the stands, time is normal for me, but for the baseball, time is like in slow motion.
Exactly. And the closer it gets to the speed of light, the more extreme that difference becomes. At near light speed, what feels like seconds to us could be years for the baseball.
Whoa, so for the baseball, maybe it doesn't even have time to realize it's about to cause an apocalypse.
From its perspective, the trip from the pitcher's mound to home plate could be instantaneous.
Instantaneous, wow. And there's another twist to this, right?
There is. It's called length contraction.
Wait, now the baseball is shrinking. What is this, some kind of physics magic show?
It's all part of relativity. Length contraction means that an object moving at a very high speed will appear shorter in the direction it's traveling.
So to the pitcher and batter, the baseball is suddenly squashed flat.
Yeah, like a pancake zooming towards home plate.
And the faster it goes.
The flatter it gets. At near light speed, the distance between the pitcher and home plate would practically vanish from the baseball's perspective.
Okay, so let me get this straight. To the baseball time has practically stopped the distance. Its traveling is almost zero, and it's squished like a pancake. This is getting weirder by the second.
It's a completely different reality from what we experience at normal speeds.
Yeah.
That's why we call it relativistic. It's all relative to your frame of reference.
It's like the baseball is leading in its own little warp dimension. But even though it's like totally trippy to think about, this isn't just theoretical, right?
Nope. We actually see these effects in the real world. Atomic clocks flown on airplanes run slightly slower than clocks on the ground. Even GPS satellites have to account for time dilation to keep working properly.
So every time I use my phone's GPS, I'm relying on Einstein's wacky ideas about time and space.
Pretty much. Relativity isn't just some abstract theory, it's woven into the fabric of our daily lives.
All right, I'm starting to see the bigger picture here. But let's get back to our city-destroying baseball for a second. We've talked about what happens before and after, but what about during that split second of impact? What would it actually feel like to witness this event?
Let's just say if you're anywhere nearby, you don't have time to feel much of anything. It would be instantaneous. Imagine a blinding flash of light brighter than anything you've ever seen as that baseball turns into pure energy.
So like a mini supernova right here on Earth.
A good analogy. The energy release would be unimaginable. But even if you were far enough away to not be instantly vaporized, the shockwave would be the next thing to hit you.
Like a wall of pressure moving at supersonic speed.
Exactly. Flatten buildings, uproot trees, anything in its path would be obliterated.
Yeah.
And the sound, unimaginably loud. It would be like the loudest thunderclap you can imagine, but amplified a million times over.
I bet even miles away, you'd still feel that shockwave hit you like a physical blow. And then, of course, there's the radiation.
A deadly, invisible wave spreading outwards. Gamma rays and other high-energy particles would flood the area. Even if you were somehow shielded from the blast and heat, this would be the silent killer.
Okay, I think we've painted a pretty vivid picture of the bad news here. So before we all spiral into an existential crisis, maybe we can talk about something a little more hopeful. Any chance we can use this power for good?
That's a great question. And the answer might surprise you. While harnessing this kind of energy sounds like science fiction, there are actually some very real possibilities being explored right now.
Really? So we're not just talking about hypothetical doomsday scenarios. There's potential for actually helping humanity with this stuff.
Absolutely. One area of research is using particle beams traveling at near light speed for cancer therapy.
Wait, so instead of wiping out cities, we could be using this to target and destroy tumors.
Precisely. The high-energy particles would deliver a very focused dose of radiation-killing cancer cells while minimizing damage to the surrounding healthy tissue.
That's incredible. It's like turning a weapon of mass destruction into a precision surgical tool.
It really highlights the duality of this kind of knowledge and power. It can be incredibly destructive, but it also holds the potential for incredible good.
Well, that's certainly a more uplifting note to end on. We've gone from a city-leveling explosion to a potential cure for cancer, all thanks to our little thought experiment.
It's been quite a journey, and we're not quite done yet. There's still so much more to explore about this idea of relativistic baseball.
Okay, I'm intrigued. What else is there to uncover? Right, I'm all ears.
Yeah.
What other secrets does this relativistic baseball hold?
Well, we've explored the devastating consequences and even touched upon some hopeful applications. But there's one final layer to this thought experiment that I find particularly intriguing. It's all about perspective.
Okay, you've definitely got my attention. Perspective how?
Think about it. We've been looking at this scenario from our earthbound perspective, seeing the baseball as this destructive force. But what about the rest of the universe?
I hadn't thought about that. You're saying there's a bigger picture here.
It's exactly. From the perspective of, say, a distant galaxy, this event on Earth might be just a blip, a tiny flicker of energy.
So our planet-shattering kaboom is just background noise to the rest of the cosmos.
In a way, yes. It highlights the vastness of the universe and the relative insignificance of our little corner of it.
That's both humbling and mind-blowing at the same time.
It really puts things in perspective, doesn't it?
Yeah.
It makes you realize that our human concerns, even those as dramatic as a relativistic baseball, are ultimately quite small in the grand scheme of things.
It's like that famous quote, "We are but a speck of dust in the cosmic ocean."
Exactly. And that speck of dust is capable of both incredible destruction and incredible creation. We've seen both sides of that coin today.
It's a powerful reminder that knowledge is a double-edged sword. It can be used for good or for bad.
And that's why it's so important to approach scientific exploration with a sense of responsibility and ethics.
Yeah.
We have to consider the potential consequences of our discoveries and use our knowledge wisely.
Well said. I think our deep dive into relativistic baseball has been a wild ride, full of twists and turns. We've explored the destructive power of physics, the mind-bending nature of relativity, and even glimpsed the potential for positive applications.
It's been a journey through the vast and complex landscape of science, and hopefully it sparked a sense of wonder and curiosity in our listeners.
Absolutely. And if this thought experiment has taught us anything, it's that even the most seemingly ordinary things like a baseball can hold the secrets to the universe's greatest mysteries.
So keep asking questions,
Okay.
keep exploring, and keep pushing the boundaries of knowledge. Who knows what other incredible discoveries are waiting to be made?
And who knows what other seemingly mundane objects might hold the keys to unlocking those discoveries. Until next time, keep those brains buzzing and never stop exploring the universe and all its wonders. Also,